Hi everyone. This is normal distribution properties, which is part 2 of your notes for this intro section here. So I went ahead and made a little note at the top. So I want to talk about the different properties that you're going to see when you deal with a bell-shaped curve, or normal curve, I should say. So let's start down through here. First of all, it's going to be bell-shaped. So you see the word normal, you think bell-shaped. Okay, secondly, and I said in the previous video, mean, median, mode are equal and located at the center of the distribution. It's going to be a unimodal distribution. Unimodal just means that there will be one mode. Okay, so one high point. That's the idea of the bell-shaped curve. Your curve is symmetrical. Okay, so we're symmetrical, it's continuous. The curve never touches the x-axis. It approaches, will not touch. It kind of just hovers there. Okay, the total area under the curve is equal to 1 or 100%. All right, so then as we've talked in a previous video, we've studied the empirical rule. So the area under the curve that lies within plus or minus 1 deviation of the mean is going to be 68%. Or if you do it as a decimal, 0.68. Okay. 2 deviations, so within 2 deviations of the mean, we know it to be 95%. And lastly, within 3 deviations of the mean, we have 99.7% of the data. Okay, but I also said that under the entire curve, we know the area to be 100%. So that means we have just a little bit out in the two tails as far as the area goes. All right, so I want to take a minute and take this idea and put it into a picture. All right, so I sketched on here a bell-shaped curve for you. All right, so I'm going to drop this in here so that your mean is going to start out here at 0. Okay, so I'm going to shift this into the standard normal. So I'm going to say the mean here is at 0. Then I'm going to go 1 standard deviation left and right of that mean. Okay, so in other words, I could say, in fact, I'll make this a little different here. So let me get rid of this. Since it's your notes, I'll write it up here just a smidge different. All right, so we'll drop this in here and we'll say, okay, we're going to go from the mean plus 1 deviation. And I probably should do this all in population notation. Sorry, I'm messing up your notes here. All right, try again. So the mean plus 1 deviation, the mean minus 1 deviation, okay, is going to fall in here. Okay, so the reason I'm doing this is because if we think within plus minus 1 standard deviation is 68%, and we know this curve is symmetrical, that tells us that on each side, we are going to have 34% of the data. Okay, so I just took 68 and divided by 2 from over here. All right, so then if we go again, if we go to the mean plus 2 deviations, okay, the mean minus 2 standard deviations, okay, so according to this, now we should have 95% of the data from here to here, so all the way across 95%. All right, so my question is then, what's the percent in these 2 new compartments that I just created here? Okay. Well, if you go out here to the side or somewhere, I have a little space here, and we say, all right, 95 minus 68, we're going to drop that out at what, 27? Divide that by 2, and we get 13.5%. So we have a 13.5 and a 13.5% in each of those new compartments. Okay, so go one more set of deviations. Okay, so if we come out to here and we say this is the mean plus 3 deviations, and I'm going out here, mean minus 3 deviations. Okay, according to that empirical rule, all the way across, 99.7%. So if you do 99.7 minus 95, that gives you 4.7 to be shared. So 2.35. in each of these two new compartments. 2.35%, 2.35%, okay? So at that point in time, okay, we have accounted for 99.7% of the data. But in the properties, it says there is 100%, or 1 is the total area under this curve. So at this point, we know there's 100 minus 99.7. So what, 0.3? And that has to be shared with each tail, out to the right and out to the left. So that's going to drop that in there at 0.15% in each tail. I'm kind of tight on this right side. Make that fit. Okay, so if you took your calculator and you went across here and you added all of these percentages, okay, and you notice they're the same on the left as they are on the right. If you add all of those up, you should get, yep, I hear you out there. If you add all those up, 100% is the area under the curve, okay? And I could certainly draw this same picture using decimals instead of percents. I just thought for this first example, we ought to take a look at it as percentages, okay? And then the last thought I want to leave you with here today, next steps will be to convert our data into what we call standard scores. Okay, the word standard. And that's going to mean that our normal distribution will have a mean of a mean of 0 and a standard deviation of 1. Okay, so upcoming we will talk about something called a z-score, and that will help us in standardizing scores. It's going to look something like this. Okay, or if we have population notation, x minus sigma over mu. Okay, and that'll be shown here in an upcoming video. All right, so again, good luck with your normal curve and being able to draw this normal curve and place those percentages in the individual compartments. All right, we'll be seeing you soon. Thank you.